All right, welcome to part 2 of managing data in SAS. First thing we're going to go over is using the by statement to aggregate by subgroups. So the first thing we're going to want to do is use a proc sort statement just to order our data in the way that we want it ordered. So our data is going to be SAS help.choose. We're going to create an out file called temp. And then I want to sort it by region. Run that. And then when it comes to actually aggregating by subgroups, create a new data set called shoes. We're going to keep the region variable, and we're going to create a new variable called total sales. Let me show you guys what this data set looks like really quick so you know what we're doing here. So this is the SAS help.shoes, and it has, I think it's 10 regions, and then each of these regions are broken up into subsidiaries, and it has all these different product categories. And then there's a different number of stores, and it lists all the sales, inventory, and return statistics for the subsidiaries within each of the regions. So in our new data file, we're going to keep the region variable, and then we're creating a new variable called total sales. So we're going to set this equal to that temp file that we just created, and we're going to use by region. And then this is where we start going over some new content. So we're using an if statement, but we're going to say if first dot region, then total sales equals 0. And then we're going to say total sales plus sales, semicolon, and finally let's say if last dot region. We'll run this and see what it looks like. This is work.temp. Let's switch it over to work.shoes, and you can see now we have sales aggregated for each region. So nothing too crazy there. This structure is going to stay pretty much the same if you want to do that. You're just swapping out different variables and such. Okay, let's comment this out. The next thing we're doing is using first dot and last dot processing to identify where groups begin and end. So that concept that we just introduced in that last step, we're going to take that another step further and figure out what the first and last observation for each region is. So actually, let's uncomment this for this step. Create a new data set called first shoe. And let's keep region, product, and subsidiary. So we have some unique values to look at. Set it equal to temp, which is our sorted data. We're going to say by region. And then say if first region. And then run it. So now we can see that we have the first entry listed in each region. So we can check that really quickly. So it's saying that the first entry for the Africa region is the boot product with the subsidiary Addis Ababa. So we'll go back to temp, and we can see that looks right. So we'll just assume it's right for the following 9 regions. And then if we wanted to do the last observation in each region, we would just switch out first with last. And you can see now it's women's dress and Nairobi. So nothing too crazy there either. So the next thing is use the retain and sum statements. So let's comment out all of our other work. Right. So we're going to create a data set called retain sum. And we're going to be specifying the input with 2 columns to start. So we'll say column 1, column 2. Then data lines. Oh, man. Okay, data lines. 1, 2, 1, 2, 3, 4, 5, and 6. And let's go ahead and print that out. This is what we're working with so far. So to build on that, we are going to start with our sum statement. So we'll create a new data set called sum1. Set it equal to retain sum. So we're going to add a third column, say equal to sum column 1, column 2. And print this. Okay. So you can see that we used the sum function, which is an important distinction, to add columns 1 and 2 together and output the result to column 3. So the other thing we can do is we can do another proc print statement and say data equals sum1. But before we run it, we can say sum column 3. And you can see that now we have this total at the bottom of column 3. And I think that that's technically a sum statement, and then what we did over here is a sum function. I could have that backwards though, but there's a little bit of a difference there, and it's just important to know. Okay, let's move on to retain. So we'll create a new data set called retain1. Set it equal to sum1. And we're going to say retain column 4 as 0. And and then say column 4 is equal to column 4 plus 1. That, and then we'll So we created a fourth column, and we initially set the value of the variable column 4 to 0 and said retain column 4 as 0. And then for each observation or iteration, it added 1 to the value of column 4. So we have 1, 2, 3, 4. And if there are more observations, that would keep going on. So it's important to have this retain step here, because if we don't specify it and we run it before, or we run it without using that retain statement, I think we'll get a missing observation for column 4. Yeah, so we have a missing observation in column 4 here. But something else we can do is we can have I think it's called an implicit retain statement. If we just take column 4 equals out, I think, let's see. Yeah, that works. So when you write the code that way, the retained statement is basically implied. So that's it for that one. Let's go ahead and comment this all out. Next one is use SAS functions such as scan, substring, trim, upcase, and lowcase to perform tasks. And then the content guide gives some specific tasks, but we'll go over all these in this example. So let's create a new data set called text manipulation. We're going to have to input some data. So we'll create a column called full. We'll say it can be anywhere between 1 and 30 characters. Lines. And we're going to put 3 observations in. They're going to be different variations of my name. So we have Trevor French without a space, Trevor French with a space, and Trevor, comma, French. Let's run that, just make sure it works. And looks like it does. So next thing we're going to do is say data text manipulation. Set it as text manipulation. I don't think we need to, but all right, now we're going to create a new variable called upcase. We're going to use the upcase function here and say upcase full. We're going to do lowcase equals lowcase parentheses full. We'll go over all of this once we actually run the program. All right, another variable called first. This one is going to be substring full 1 and 6. Then we're going to say last also. Same idea here. And then finally, we're going to do a scan last variable. We'll say scan full -1. Then we're going to be running that. Let's go ahead and do a proc print. Data equals manipulation. And let's go ahead and just throw a title on there. Let's run it and see if we have any errors. Oh, looks good. All right. So you can see we have 3 initial observations that we started with. Upcase took those observations and just made everything uppercase, lowercase, the opposite. First and last, what we did is we used this substring function. I don't know if that's what it's called, but that's what I'm calling it. And the first parameter is the observation that we want to work with. So in this case, we said the full variable, and we said to start at position 1 and end at position 6 and return all the characters in between that. And then on last, we did 7 and 12. So you can see for this first one, we got Trevor in French because T was in the first position and R was in the 6th position, and then F and H in the 7th and 12th positions. Here, the program just skipped over that space in the middle, but then this last one, the program doesn't skip over the comma, so it included it. And then the scan first and scan last, basically what this function is doing is it's looking for any sort of delimiters. So in our case, the delimiters were the space and the comma in the last 2 observations, but there weren't any delimiters in the first observation. So it worked for the last 2, but not the first one. And then specifically for this first one, we told it to return the first observation from the left. So basically when it's looking for delimiters, it breaks up an observation or a variable into multiple observations with the delimiter signaling where each of those observations begin and end. And with the -1, it's doing the same thing. It's just reading from right to left instead of left to right. So you wouldn't even have to use a 1. You could say -4, -5, and it would read from right to left instead of from left to right. Okay, so we covered everything there except for the trim function. And for this one, I'm just going to use what the SAS documentation uses, just because it's quick and easy. I don't think we need to spend too much time on it. So I'm just going to copy and paste it in here. So what we're doing is we're creating a new data set called test, and then we're creating 2 variables called part 1 and part 2. And then inside the statement, we're creating a 3rd variable called hasBlank, which is equal to part 1, and then it's concatenating part 1 and part 2. And then noBlank is using the trim function on part 1 and then concatenating it with part 2. And then the data is apple and then like 6 spaces and then sauce. So we'll run it and see what this looks like. All right, so you can see part 1 is apple, and then there's some trailing blanks that we can't see here. Part 2 is sauce, and then when we concatenate without using the trim function, it keeps all those blanks. And then if we concatenate with the trim function, it eliminates all those trailing blanks. So that's that. I think we can move on. Next one is use SAS numeric functions such as sum, mean, rand, smallest, largest, round, and int. So let's go ahead and create a new dataset called numeric. We're gonna input 4 variables A, B, C, and D. Create a 5th one called sum. Say sum A, comma B, comma C, comma D. 6th one called mean. Same idea here, mean parentheses and variables that we want to include in mean. And then random, we're going to use the rand function. And this function creates just a random variable for you to use. There's a bunch of different options that you can use to create this random variable with different distributions and different methods of coming to that random variable. But a really common one to use, and what we're going to use right now, is called uniform. It's return a decimal between 0 and 1, and I think there's 6 decimal places, and then you can multiply it after the fact with anything you want. If you want it to be between 1 and 100, you can multiply that and get what you want out of it. All right, I'm going to create another variable called smallest. Say use the smallest function. Same thing here, A, B, C, D. And then largest, and we're going to use the largest function, do the same thing. And then round, use the round function. And this one, we'll go ahead and just round our sum variable that we just created. Then you have to specify to what degree you want it rounded to. So we'll just type 10. But if you want it rounded to the nearest tenth, for example, you could just type 0.1. So 10. Then last variable is going to be int, which just returns the integer value of a specific variable. But for this, we'll just do sum. And we'll put our data in. And let's do a proc print. All right. We've got our first 4 variables, A, B, C, D, with basically some random numeric data. We created sum with a sum function, which adds our 4 variables together. Mean, which does our average. Random, we just created a random integer between 0 and 1. And I was wrong, it's 5 decimal places, it looks like. Smallest returns the smallest of the 4. Largest, the largest. Round, rounds them all to the nearest 10. So they're all 10 here because we did the sum column. and then int just gives us the integer version of our data. So nothing too crazy there. Most of that's pretty straightforward. To find the sum, you're using the sum function, mean, you're using the mean function, smallest, and so on. Right, the next one is create SAS date values by using the functions MDY, today, date, and time. So let's create a new data set called dates. We use the MDY function straight away and say UI is equal to UI. And then, as you could probably guess, MDY stands for month, day, and year. So let's do today's date, 6/4. So we're giving MDY a date value that's equal to today's date. Now we'll use the today function. And for this one, all we need to do is say today and then parentheses and then close it. And it should give us today's date. And then same thing with date. It should return today's date as well. And finally, we're going to do time, the time function. And that should return the current time. So let's run that. Log, no errors or warnings. And you can see MDY has value of today's date, as does today and date, and then time. That should be the current time. I'm not sure, but I'm assuming it is. And if you wanted to format that, you could do that, which I've gone over in a previous video. All right. For the next one, I'm going to copy this down. We're going to be extracting the month, year, and interval from a SAS date value by using functions year, quarter, month, and day. So all we're going to do here is create some more variables on this data set. So for the month variable, we'll use the month function. And we're going to tell the program to get the month value from our date variable. And then for our year variable, same concept. And print the same for day. So you can see we are pulling the month, the year, the quarter, and the day from this date variable. So it's the 6th month, year's 2020, we're in the 2nd quarter still, and the day of the month is the 24th. And then finally, we're going to be performing calculations with date and date time values and time intervals by using the functions intck, intnx, dat, dif, and yeardiff. So we're going to create another variable called int ck. Int will do int ck, and then our parameters are a main date, next date. I'll go over all this once we run the program. Just follow along and see if you can figure it out through the logic until then. I create another variable called int inx. Use the int inx function. We're going to specify day. And then our next parameter is going to be main date variable. And then we're going to say 4. Date diff, date diff. Parameter is going to be main date, next date, and then ACT/ACT. And the same for year date, year diff. All right, let's put some data in here. Okay. So our main date was 4 days ago. The next date is today. Int ck, we put day. So that's the intervals that it's counting. It's counting how many days are from main date all the way to next date. So our value should be 4, and it looks like it is. All right, for int inx, we specified the interval and said day, and then we said main date 4. So what this is doing is instead of counting the number of days between two dates, it is adding 4 days to the date that we specified. So we added 4 days to 4 days ago, and it should return today, which it looks like it did. Then date diff, we said main date, next date, and then we specified this parameter right here, ACT/ACT. And what that's saying is it's counting the actual number of days between these two dates. And you have to specify that because there are other options, like if you're using a banking calendar, it could be 360 days rather than 365 days. And then there's some other options in there too, but this is probably the one you'll use most of the time. So this should be 4 also. And then year diff, same principle here, except it's counting the number of years. So we've got a really small decimal because it's only 4 days. All right, that's it for that one. Thanks for following along. I'm going to come out with part 3 of managing data here pretty soon, and then I think we're moving on to error handling. If you have any questions, let me know in the comments, and thanks for watching.